Welcome, curious minds, to another deep dive. Today, we're doing something really fundamental, something humans have done forever, really. We're looking up to that incredible night sky, that, sparkling canvas that's just captivated us for millennia.
It really has. There's just this universal feeling when you look up, isn't there?
Yeah, that sense of wonder, connection, maybe feeling a bit small, but also, invited to explore.
Absolutely. It cuts across all cultures, all of time. I mean, from the earliest people charting seasons to us sending probes out now. The stars have always been, well, our storytellers, our clocks, our guides.
And today, we're zooming in, we're looking at some of the most recognizable patterns up there, Ursa Major and Ursa Minor. Now, you probably know them by their more common names, right? The Big Dipper and the Little Dipper.
That's them. And we'll also spend some good time with that really key star, Polaris, the North Star. It kind of anchors that whole part of the sky.
Our sources for this one are, well, they're a fascinating mix. We've got hard astronomical data, sure, but also these amazing cultural legends from all over the world, stories passed down forever.
Yeah, and even practical sky-watching guides, stuff that echoes methods used thousands of years ago. It's a real constellation of info, you could say.
Huh. Nice one.
Yeah.
So our mission today, we want to pull out the really key insights from all this, everything from how ancient people navigated using these stars across oceans, deserts, you name it, to, cutting-edge discoveries about the stars themselves, what they are, what they're doing.
We really want to show the rich tapestry of human knowledge woven into these celestial bears. It's not just what they are, but why they've meant so much to us, to humanity, for so long.
Exactly, why they matter to you. So, yeah, let's unpack this.
Okay, let's start with something that often trips people up, even people who look at the stars a lot. The difference between a constellation and an asterism. People tend to use them interchangeably, but astronomically speaking, they're distinct.
Right. Like, everyone calls the Big Dipper a constellation, but technically, that's not quite it, is it? Can you break that down?
Precisely. So a constellation, officially, is one of the 88 areas that the sky is divided into. Think of it like countries on a world map, but projected onto the sky. These were standardized by the International Astronomical Union, the IAU, back in the 1920s, define regions' specific boundaries.
Okay, so the whole sky is carved up into these 88 official zones, like cosmic real estate.
Exactly. Every star, every galaxy, everything up there belongs to one and only one of these constellations.
And within those zones, you might see familiar patterns, shapes that jump out.
That's where asterisms come in. They're recognizable patterns of stars, often really prominent ones, but they aren't constellations themselves. Sometimes they're part of a larger constellation. Sometimes they even use stars from multiple constellations. They're like visual landmarks, unofficial but super useful.
And the Big Dipper is a perfect example. It's not its own constellation, but this really obvious asterism. It actually forms the tail and the back end of the much larger constellation. Ursa Major, the Great Bear.
That's it exactly.
Right.
When you see the Dipper, you're only seeing a part, albeit a very bright part, of the Great Bear.
And the Little Dipper is the same idea, right? An asterism inside Ursa Minor, the Little Bear.
Yep. In this distinction, it really matters if you want to understand the sky properly. Asterisms are great visual guides, easy to spot, easy to remember. But the constellations are the official map coordinates, That's what astronomers use worldwide to say, look here. It's crucial for consistent mapping and communication.
Got it. Asterisms are the shortcuts, constellations are the official territories. Makes sense. Okay, let's dig into Ursa Major, the Great Bear. Our sources say this thing is massive.
Oh, it is. It's huge. Third largest constellation in the entire sky, covering almost 1.3% of it. And for those of us in the Northern Hemisphere, it's the biggest one up there. The full bear is way bigger than just the Dipper part.
And it's circumpolar for us Northerners. What does that actually mean for us looking up? Why is that important?
It means it never sets, never dips below the horizon. If you're far enough north, Ursa Major is visible all night, every night, all year round. It just circles around the North Star, Polaris. You'll see its position change through the night and through the season. Sometimes it looks like it's upright, sometimes upside down.
Right, like it's pouring something out or standing on its handle.
Exactly, but it's always there. That constant presence made it incredibly reliable for ancient observers, a fixed point in a moving sky.
So it's always up there, which is cool, but you got to remember the Dipper is just part of it. Because the whole bear includes fainter stars, right? Harder to see, maybe, especially with city lights.
It's a key point. The Big Dipper is so bright and obvious, it acts like your signpost to find the rest of the Great Bear. Without that familiar shape, Tracing the whole thing would be pretty challenging for most people. Its size is impressive, even if we mostly just notice the asterism.
Okay, and then its little buddy, Ursa Minor, the little bear. Smaller, ranked 56th in size, but still packs a punch, right?
Absolutely. Size isn't everything here. Ursa Minor is hugely important, mainly because it contains Polaris, the North Star, right at the tip of the Little Dipper's handle. And just like Ursa Major, it's also circumpolar for the northern hemisphere. Always visible, always circling the pole.
But I've heard the Little Dipper itself can be harder to spot than the big one, especially if there's light pollution.
That's definitely true, and it highlights why Polaris is so vital. The stars that make up the Little Dipper's bowl and most of its handle, they're much fainter than the Big Dipper stars. In cities or suburbs, you might only see Polaris and maybe one or two others. The rest just fade into the sky glow.
So Polaris becomes the main clue, the thing you look for to even know where Ursa Minor is.
Exactly. It's the anchor. It really shows the North Star's importance both positionally and visually.
It's fascinating how these two are linked. Names, location, but also this shared history of guiding people, inspiring stories.
Totally. They weren't just dots of light, they sparked imagination. Led to myths, cultural narratives, tied into navigation. They were like cosmic multi-tools.
Speaking of stories, you can't talk Ursa Major without the Greek myth. Probably the most famous one, right?
Yeah.
Jealousy, transformation, classic Greek drama.
Oh yeah, the story of Callisto, a nymph, a follower of Artemis, and, well, she got the eye of Zeus, king of the gods.
Never a good sign in Greek myths.
Rarely. They had a son, Arcus. But Zeus's wife, Hera, she found out. And Hera's jealousy was legendary, so in a rage, she transformed Callisto into a bear.
Ouch. So Callisto's stuck roaming the woods as a bear. That's rough.
Brittle. Years pass. Her son, Arcus, grows up to be a hunter. One day, he's hunting, sees a bear, doesn't realize it's his mother, raises his spear.
Oh, no. Right before Zeus steps in, got to prevent that tragedy.
Exactly. Zeus sees what's about to happen, feels sorry for Callisto, and acts fast. He grabs her by the tail, the story goes, and swings her up into the sky.
By the tail. Is that why the Big Dipper's handle looks so long?
That's the mythological explanation. Lifting her stretched the tail to an abnormal length. And in many versions, he puts Arcus up there too, as Ursa Minor. Mother and son, forever in the sky.
Wow. And the myth explains the circumpolar thing too, right? They're cursed or destined to circle endlessly, never setting, never resting beneath the ocean.
Yes. It connects the story directly to the observation. For observers in Greece, these constellations don't set, so the myth gives a reason why. They're eternally circling the pole, a punishment or maybe a form of protection from Hera. It's a brilliant piece of narrative sense-making.
Trying to explain the cosmos through story, it's powerful. But the Greeks weren't alone in seeing bears up there. Native American traditions also have incredibly rich bear stories tied closely to their world.
Absolutely. Indigenous star lore across North America is incredibly diverse and profound. Take the Haudenosaunee tradition, that's the Mohawk, Oneida, Onondaga, Cayuga, Seneca, and Tuscarora peoples. For them, the 4 stars of the Big Dipper's bowl are the bear, and the 3 handle stars, they're hunters, robin, chickadee, and moosebird, forever chasing the bear.
So it's not just a picture, it's a chase scene, playing out across the sky, changing with the seasons.
Precisely. The story follows the pursuit from spring through autumn. The bear always stays just ahead as the constellation rotates around Polaris.
Until the fall, does the chase end?
Well, in the autumn, the story goes, the bear gets tired, maybe slows down. Robin, the closest hunter, finally wounds it with an arrow, and the bear's blood spills down onto the earth. And that's what colors the leaves red and orange in the fall.
Whoa. That's
Yeah.
beautiful, connecting the stars directly to the changing autumn leaves.
It is. And some of the blood splatters onto Robin himself, giving him his red breast. It's this intricate weaving of sky events and earth events.
Incredible. And the Micmac people have a similar story too. Bear and hunters.
Yes, a variation on the Great Bear and 7 Hunters theme. In their version, Mazar, that star in the Dipper's handle, is Chickadee, and its faint companion, Alcor, is his cooking pot he carries. These aren't just tales, they reflect deep observation of nature's cycles.
It really makes you appreciate traditional native science knowledge, seeing connections maybe modern science overlooks sometimes, insights from living with nature.
Definitely. And it raises that fascinating question, why bears? Why did so many separate cultures look at those stars and see a bear? Greece, North America. It's not an obvious bear shape, is it?
Not really, no.
It suggests something deeper, maybe a shared ancient root, maybe something about human perception, seeing powerful figures in the sky. It's a puzzle.
A very cool puzzle. And it wasn't only bears either. Other cultures saw different things entirely, right?
Oh, completely.
Yeah.
Ancient Egyptians saw as an ox, or the thigh or foreleg of a bull, part of a larger celestial scene tied to their god set.
An ox.
Ancient Chinese astronomy saw it as a celestial bureaucrat, like a government official being carried in a chariot or on a cloud,
Whoa.
projecting their society onto the sky.
Even Polynesian navigators used it, didn't they? As part of their star lines for finding their way across the Pacific.
Yep, part of the seven for them, a practical tool. This amazing diversity just highlights how humans everywhere look up and try to make sense of it all, weaving meaning, finding guidance.
From myths to morals to maps. Which brings us squarely to navigation. And the absolute linchpin for northern navigation, Polaris.
Polaris, the North Star,
Mm.
brightest star in Ursa Minor. Its importance comes down to location, location, location. It sits almost directly above Earth's geographic North Pole.
Okay, let's break that down. Why does being above the North Pole make it seem unmoving while other stars wheel around?
Okay, imagine Earth spinning like a top. The line it spins around is its axis, going through the North and South poles. That axis points to a spot in space, the North Celestial Pole. Polaris happens to be incredibly close to that spot, so as Earth spins over 24 hours, everything else seems to circle around that spot.
Like the center of a merry-go-round. The horses on the edge move a lot, but the very center stays put.
Exactly like that. Because Polaris is so close to the center point, technically it makes a tiny circle, about 1.4 degrees wide, but to our eyes it looks stationary. That makes it a super reliable marker for true north. If you face Polaris, you are facing north, period. Incredibly useful before compasses, before GPS.
Amazing, a cosmic anchor point. So for someone listening, how do you find it? Using the Big Dipper, right?
Yep, the Big Dipper is your friend here.
Hmm.
First, spot the dipper. Find the two stars at the end of the bowl, the ones furthest from the handle.
Duhet and Merak, the pointer stars.
Those are the ones. Now imagine drawing a line starting from Merak, the one closer to the handle base, going through Duhet and keep going out into space. Extend that line about 5 times the distance that's between Merak and Duhet. And boom, you should land right on Polaris.
And it's not the brightest star in the whole sky, but it's noticeably bright in that area, and it's the end of the Little Dipper's handle.
Exactly. Practice it a few times, it becomes second nature, a really fundamental stargazing skill.
And historically, incredibly powerful. Our sources highlight the Underground Railroad, enslaved people using the Big Dipper, the drinking gourd, to find Polaris and navigate north to freedom.
It's one of the most powerful examples of practical astronomy meeting human courage. Without maps, without compasses, often traveling only by night, they read the stars. Following that drinking gourd to Polaris meant heading north towards liberation. It's just awe-inspiring, bravery and ingenuity guided by the night sky.
Truly humbling.
Yeah.
Makes the stars feel very real, very immediate. But here's a twist. Polaris hasn't always been the North Star, right? The sky changes over long periods.
That's correct. It introduces this mind-bending idea of deep astronomical time. Earth's axis does this slow wobble, like a spinning top starting to run down. It's called axial precession. One full wobble takes about 26,000 years.
26,000 years. Wow. So over that cycle, the direction the North Pole points drifts across the stars.
Exactly. So different stars get their turn being the North Star. Around 3000 BC, during the time of the Egyptian pyramids, the North Star was Thuban, in the constellation Draco the Dragon.
So the pyramids might have been aligned using Zubin.
Some evidence suggests passages were aligned towards Theban when it was at its closest point to the pole, yes. And looking way ahead, in about 12,000 years, the bright star Vega will be the North Star.
So our fixed North Star is only fixed for our current little slice of time. The cosmos is always in motion. What about the Southern Hemisphere? Do they have a convenient South Star?
Sadly for them, no. There isn't a bright star right near the South Celestial Pole like Polaris is for us. Navigation is a bit trickier down there.
So what do they use? How do you find South?
They mainly use the Southern Cross and asterism within the constellation crux. You draw a line through its longest axis and another line perpendicular to the two pointer stars nearby, and where those lines intersect is roughly the South Celestial Pole. A bit more involved.
Shows how resourceful people are, using whatever sky markers they have. Okay, so these patterns guide us on Earth, but let's look into them. Deep sky wonders. Starting back with the Big Dipper handle, Mizar and Alcor.
Ah, yes, the famous naked eye double. If your eyesight's good, you can split them into two stars without any help. An ancient eye test.
Tell us more about that. Used by archers or something.
Yeah, reports from Persia and Bedouin cultures mention using it to test vision, maybe for military roles. Al-Khor was sometimes called the test, or our riddle in Arabic traditions. A 13th century Persian writer literally said people tested their eyesight by this star. And in Japan, there was even a folk belief connecting seeing Al-Khor to longevity. If you couldn't see it, maybe your time was short.
A bit ominous. But the real story of Mizar and Alcor is way more complex than just two stars, isn't it? Get ready for this.
Oh, it's fantastic. So, Mizar itself, the brighter one. First, in 1650, an Italian astronomer saw it was actually two stars through his telescope. The first binary star system discovered. But wait, there's more. Later, astronomers using spectroscopy found that each of those two stars making up Mizar is itself a binary.
Wait. So Mizar isn't one star, it's two.
Yeah.
And each of those two is also two. So Mizar's four stars.
You got it. Mizar is a quadruple system, four stars orbiting each other. But we're not done.
No. What about Alcor?
Alcor, the fainter companion. Turns out in 2009, they discovered it's also a binary system. Two stars orbiting each other.
Okay, my head's spinning. Mizar is four stars, Alcor is two stars, so together that's six stars.
Stars. A gravitationally bound sextuple system, all appearing to us as just one or maybe 2 points of light. It's incredible complexity hidden in plain sight.
That is seriously mind-boggling.
Yeah.
Six stars masquerading as one or two.
Wow.
Huh.
And culturally, they meant more than just an eye test, right? You mentioned India. Yes, in Hindu astronomy, Mizar is Vasishta, one of the seven sages, Saptarishi, and Alcor is Arundhati, his wife. They symbolize the ideal marriage, close, devoted, yet distinct. Sometimes during Hindu wedding ceremonies, the couple is shown these stars as a blessing for harmony and closeness. It's beautiful.
That really is lovely. And other names, too. Horse and rider, chickadee and his pot.
Yep, English folklore had horse and rider. And the Micmac story we mentioned saw Mizar as chickadee and Alcor as his cooking pot. So many layers, science, myth, culture packed into those stars.
Amazing. Okay, let's move over to Ursa Minor again. Beyond Polaris, what else is hiding in the Little Bear? It seems quieter than Ursa Major.
It is generally less crowded with bright, deep sky objects, but it still has some real gems, like Kochab and Firkad.
Guardians of the Pole. What's interesting about them?
Kochab is an orange giant star, bigger, cooler than our sun. And get this, astronomers think it has a planet, a gas giant about 6 times Jupiter's mass, orbiting every 522 days.
An exoplanet in Ursa Minor. Cool. And Firkad.
Firkad's a white, bright giant, and it's a variable star, a specific type called a delta Scuti variable. Its brightness pulsates really quickly over just a few hours. These stars are super important. They act as standard candles for measuring cosmic distances, and studying their pulsations, astroseismology tells us about what's going on inside them.
So even these guardian stars are dynamic and scientifically valuable. And there are other variable stars in Ursa Minor, too. Stars that change brightness.
Oh, yes. You've got red giants like R, S, RR, and T Ursae Minoris. Some of them pulse, expanding and contracting. T Ursa Minoris actually had a dramatic change in its pulse period back in '79, probably due to a helium flash deep inside. Then there's Z Ursae Minoris, a rare type, and R Corona Borealis variable. It suddenly dimmed massively in 1992, probably because it puffed out a cloud of carbon soot that blocked its own light, like a star suddenly putting on sunglasses.
Stars throwing out soot clouds.
Yeah.
What about eclipsing stars?
Yep, got those too. W and RU Ursa Minoris are binary systems where the stars orbit edge onto us so they pass in front of each other, causing regular dips in brightness. RU is particularly interesting. One star is actually dumping material onto the other, a semi-detached system.
One star feeding off the other. Cosmic vampires.
Sort of. And then there's RW Ursae Minoris. That's a cataclysmic variable, usually a white dwarf pulling material off a companion star. This leads to massive outbursts. RW flared up as a nova in 1956, bright enough to see without a telescope. It's still brighter than it was originally, even decades later.
Wow, exploding stars, cannibal stars. Ursa Minor isn't so quiet after all. Any other really weird objects hiding there?
A few more standouts. There's the Ursa Minor dwarf galaxy, a faint satellite galaxy of our own Milky Way, about 225,000 light-years away. Very old, mostly stars. Then there's Calvera, an isolated neutron star. That's the super dense core left after a massive star explodes. One of the closest known neutron stars to Earth, just sitting there spinning incredibly fast.
A neutron star.
Yeah.
Okay. What else is weird?
How about the hottest known white dwarf? H1504 plus 65. Surface temperature of 200,000 Kelvin. Our sun is, like, 6,000 K. And its atmosphere is bizarre, mostly carbon and oxygen, almost no hydrogen or helium. We don't fully understand how it got that way.
200,000 K? That's unbelievably hot. And a weird atmosphere, too. And closer by.
Wise, 1506 plus 7027. That's a brown dwarf, a failed star, only about 11 light years away. Practically a neighbor.
So much variety.
Oh,
And we can't forget meteor showers, right?
right. Ursa Minor hosts the radiant for the Ursids meteor shower. Peaks around December 18th to 25th. Tiny bits of dust from Comet 8P Tuttle burning up in our atmosphere. A nice little celestial fireworks show, courtesy of the little bear.
Cosmic holiday gift. Okay, let's swing back to the Great Bear, Ursa Major. It's famous for holding some spectacular galaxies, right? Things you can see with amateur telescopes.
Absolutely. Ursa Major is galaxy hunter territory. Prime example, Bode's galaxy M81. It's gorgeous, one of the brightest galaxies out there, about 12 million light years away.
12 million light years. And what's it like?
A beautiful spiral. Its arms are full of young, hot blue stars. The center has older, redder stars and a supermassive black hole, maybe 15 times heftier than the one in our Milky Way center.
15 times.
Yeah.
Wow. And right next door, often in the same view, is M82, the cigar galaxy.
Exactly. They're gravitationally interacting, which is probably why M82 looks like it does. It's a starburst galaxy. It's churning out new stars like crazy, maybe 10 times faster than our galaxy is. All that gas getting compressed triggers furious star formation. Looks like a glowing cigar.
A galactic cigar on fire with new stars. Then there's M101, the Pinwheel Galaxy. Sounds lovely.
It is a huge face-on spiral, much bigger than the Milky Way, maybe 170,000 light years across. And it could have a trillion stars. Yeah, a trillion.
A trillion stars. It's hard to even comprehend. And seeing these is like looking back in time, right? Because the light takes so long to get here.
Precisely. When you look at M101, you're seeing light that left 21 million years ago. You're looking deep into cosmic history.
What about Izwiki 18? That one sounded odd. Youngest galaxy.
That was the initial thought. It looked like it might only be 500 million years old, which would be incredibly young for a galaxy. But later studies found older stars hiding inside. So the current thinking is it's actually old, but it's just been forming stars incredibly slowly for some reason. A real puzzle. A galaxy taking its sweet time.
The universe keeping us guessing. And the Hubble Deep Field, that iconic image of thousands of distant galaxies that was taken looking through Ursa Major, wasn't it?
Yes, the original Hubble Deep Field pointed to a seemingly empty patch of sky in Ursa Major. They stared at it for 10 days straight back in '95 and revealed over 3,000 incredibly faint, distant galaxies, looking further back in time and space than ever before. Just mind-blowing what was hiding in that empty spot.
Truly incredible. All these wonders, from nearby stars to the edge of the observable universe, visible within these familiar patterns, which really underscores how important it is to be able to see the night sky.
Which brings us to a really critical issue today, light pollution.
Yeah, all the artificial light from cities, streets, buildings.
Yeah.
It's washing out the stars, isn't it?
It absolutely is. It creates this background glow that makes faint stars, nebulae, galaxies invisible. For billions of people now, seeing the Milky Way is impossible from where they live. It's become a myth.
That's so sad. To think what we're losing, that connection our ancestors had, that sense of scale.
Exactly. We're disconnecting ourselves from this fundamental human experience. For millennia of knowledge, navigation, storytelling, spiritual connection tied to the night sky, it's not just about pretty views. It affects nocturnal wildlife, wastes energy, and diminishes our sense of place in the cosmos. Even simple things help shielding lights so they point down, using warmer colored bulbs, turning off lights we don't need.
And there are bigger efforts, too. Like dark sky parks.
Yes, thankfully. The International Dark Sky Association certifies places, parks, reserves, even whole communities that actively work to protect the night sky from light pollution. Places like Dinosaur National Monument or Mesa Verde National Park here in Colorado, they offer truly dark skies, letting you see the stars the way they were meant to be seen. It's crucial for preserving that heritage.
It really ties back to what you said about traditional knowledge, like the Native American stories. That came from deep observation of nature, of the real night sky.
Precisely. And while modern science has amazing tools, sometimes it can overlook the depth of insight in traditional knowledge systems. There's a richness in combining meticulous observation with cultural understanding, ecological awareness, seeing the whole picture.
Which connects to the future, right? Inspiring the next generation of astronomers, maybe bridging those different ways of knowing.
That's the hope. Our sources really stress how important careers in science are, especially for Native students, bringing that unique perspective, potentially blending traditional knowledge with modern exploration. Imagine the insights possible. Hopefully, dives like this spark that curiosity about the science, the stories, and how they connect, encouraging people to look up and learn more.
So as we wrap up, we've journeyed through Ursa Major and Ursa Minor, these familiar shapes holding ancient maps, cultural epics, and incredible science. From guiding people across continents to revealing six-star systems and galaxies billions of light years away.
They really are more than just patterns. They're like living records of human curiosity, our need for meaning, our ability to navigate our world and our imagination, anchors in time.
So when you look up tonight, maybe you see the whole Dipper, maybe just Polaris poking through the glow. Think beyond the dots of light. Think about the myths, the navigation, the escapes to freedom, the mind-bending science, all illuminated by these same stars throughout history. And consider how they still invite you to look deeper, to wonder, and maybe even find your own story written in their ancient light.